Hello all, welcome back. Continuing on the journey of biochemistry, bioinformatics, and also implementing it with Python. So we are applying AI kit and XGBoost chemistry for chemistry for predicting the solubility of chemical compounds from the SMILES notations, as we have mentioned on SMILE notation in the previous video itself within Intel Developer Cloud. So it's a project that is completely based on oneAPI. We are predicting the solubility of chemical compounds from the SMILES. Now what we are trying to do, we will be building the application with Intel Developer Cloud. We'll be using oneAPI AI Analytics Toolkit with XGBoost. We're building the application within Jupyter Notebook with base kernel enabled. The code is designed to work with chemical data, particularly focusing on predicting of solubility of set of chemical compound based on the structural features. So in this particular code itself, you'll see that we have implied machine learning into it, and we have used concepts of XGBoost in it and have come to the prediction results itself. So the code workflow. So first of all, it imports necessary libraries. It uses rdkit for chemical informatic tasks, pandas for data manipulation, numpy for numerical operation, and xgboost for machine learning. So first of all, it loads the data. So the loading the data that we have done is using Intel's Modins library. I've created a CSV file named as synthetic data 1.csv, contains chemical compounds represented by SMILES notation, a text string representing the structure of chemical compound, and target property to predict in case of solubility. Will preprocess and compute descriptors. A function compute descriptors is defined to compute molecular descriptors for each compound. These descriptors include molecular weight, logarithm of a particular partition coefficient, number of hydrogen bond acceptors. These words are very common in terms of chemistry we are dealing with. So they are created in the CSV file in different formats, and these are columns. Number of hydrogen bond donors, these are calculated using rdkit chem descriptors module for each molecule converted from SMILES notation. If a molecule cannot be processed, it returns not found for each descriptor. So again, the code workflow is continued. Data preparation for machine learning. The computed descriptors are added to the data frame as new columns. Rows with missing values are dropped to ensure the model trains on complete data. The data set is then split into features X and target Y, which are used to train the machine learning model. So model training, we are using the Intel XGBRegressor model from XGBoost library, which is trained on the prepared data. The model learns to predict. So we are predicting the solubility based on the molecular descriptors. Prediction, the trained model is used to predict solubility for the dataset, and these predictions are added to the data frame as a new column. Visualization itself, finally an interactive widget is being created using IPI widgets, and rdkit came draw visualize a molecule. The widget allows us the user to set a threshold for predicting solubility and displays the structure of molecules with predicted solubility above the threshold. The interact function creates a slider based on the range. So you'll see in the widget that we have created, it will create a slider based on the range of predicted solubilities in the data, and as the user adjusts the slider, the corresponding molecules are displayed. So in terms of workflow for machine learning training, this is where Intel's optimization can significantly impact when training XGBRegressor model itself. If XGBoost is compiled with support for Intel optimization that we have already done, the training process can leverage multi-core CPUs and SIMDs instructions for faster computation, results in quicker model training times, and can improve model scalability and dealing with the large data sets. Prediction and visualization. Similarly to the training phase, prediction made with the XGBRegressor model can be also benefit from Intel's hardware optimization. We'll just see it in action. So I've opened up my Intel Developer Cloud Console. We are using the normal cloud itself. We haven't initiated or launched any instance. So as you can see, like we can definitely work with the normal model that's there. So we are into the Jupyter lab here. Install the rdkit as well as we have the AI kit and XGBoost. This is the example that's already been provided. What I have done is that I have uploaded the CSV file over here that was created using Modern, and the predicted solve IPython notebook, as I mentioned, goes through importing first of all the descriptors. Then we read the dataset that's being already loaded over here. We pre-process and compute the descriptors as mentioned. You can see, and also dropped any values that's there. And after that using XGBoost regressor, we are just distributing it into X and Y values, training it using XGBRegressor model. Then we are doing a model fit and from there we are predicting the predicted solvability for that. As you can see, when you are running this, the scikit-learn is enabled, Intel optimized scikit-learn. We have initialized the IPy widgets, and we can visualize the molecules. So how it works, like as we have trained it into a particular data of CSV file, you can change the values of the threshold, and each threshold would show you different kind of molecules for it because it's being trained. So as you can change the threshold values from a particular range itself, you'll see that the molecules changes and you will see different compounds for this. So it's a one of a kind experience that I have done in oneAPI, and it's tackling a problem of using or applying machine learning in terms of predicting molecular solubility and also visualizing the content for it when you are just changing the threshold values on the trained model itself. So it's happening real time. You'll see the changes happening, the molecules are being created. Definitely I would request that I have shared the code. Anybody can tweak it and change it to its liking, and it's like the same journey that I'm continuing for learning and sharing. So hopefully everybody would like it, and please subscribe to my channel so that I can also contribute more, and as I contribute, learn and contribute more during my PhD sessions, or say when I am doing my coursework, I can also share my findings over here. So that's it. Thank you.